All right, let's take a look at our review questions here and see if we can come up with some answers. First, it says use the distributive property to simplify the following expressions. So we are going to notice that the only value outside of my first parentheses here is a 1. So really that's just x plus 4. And I'm going to distribute a negative 2 through my second set. So negative 2 times x is a negative 2x. Negative 2 times positive 5 is a negative 10. So if I combine like terms, I get 1x minus 2x, which is a negative 1x. And I have a positive 4 minus 10, which is a negative 6. In my second example here, I have 1/2 times 4z. So 1/2 times 4z is 2z. And I have 1/2 times positive 6, which is 3. In example 3, we want to go ahead and notice that we are distributing a negative 1 through our second set of parentheses. So we have 4 plus 5 in our first one, but we have negative 1 times 5, which is a negative 5, and a negative 1 times 2, which is a negative 2. So when I combine like terms here, 4 plus 5 is 9, 9 minus 5 is 4, 4 minus 2 is 2. In number 4, let's distribute the x. So x times x is x squared, and x times 7 is 7x. In number 5, let's distribute the y. So we get x times y, which is xy, plus y times 7, which is 7y. In number 6 here, let's distribute the 13x. So we get 13x times 3y. So 13 times 3 is 39. And we have our xy. Plus 13x times z, which is just a 13xz. For number 7, let's go ahead and distribute our x. So we get 3x times 3 over x, which is 3x over x, plus x times 5, which is 5x. And if we want to go ahead and simplify, notice that x over x is just 1. So really, it's just 3 plus 5x in example 7 here. And the last one, let's distribute xy. So xy times 1 is just xy over x. And then xy times 2 is a 2xy over y. Notice again, if I want to simplify those, I'm left with y plus 2x. Next, we're going to use the distributive property to remove the parentheses from the following expressions. So let's go ahead and distribute that 1/2 to get 1/2 x minus 1/2 y minus 4. In number 2 here, we're going to distribute the 0.6. So 0.6 times 0.2x is 0.12x. And 0.6 times 0.7 is 0.42. Notice that I am distributing a positive 1 through my parentheses in number 3, so it's 6 plus x minus 5 plus 7. If you wanted to go ahead and combine like terms, 6 minus 5 is 1, and 1 plus 7 is 8. Now, notice 3 and 4 are very similar, only instead of distributing a positive 1 through the parentheses, now we're distributing a negative 1. So it becomes a negative x plus 5 after I distribute. So I'm left with the negative x. 6 plus 5 is 11, and 11 plus 7 is 18. In number 5 here, we have to distribute the 4 to get 4m plus 28. And then we have to distribute the negative 6. So negative 24 plus 6m. If we want to combine like terms there, 4m plus 6m is 10m, and 28 minus 24 is a positive 4. In number 6, we're going to distribute the negative 5, so we get negative 5 times y. And negative 5 times negative 11 is a positive 55. And if I'm going to combine like terms, that leaves me with a negative 3y plus 55. In number 7 here, we have to distribute the negative 1 for starters, so that's a negative x plus 3y. And then we have to distribute the 1/2, so that's a positive 1/2 z plus 2. And for the last one here, let's distribute a over b throughout the parentheses, so that would be a 2a over ab plus a 3a over b squared, because b times b is b squared, and then an ab over 5b. And if I want to go ahead and simplify this, notice the a's there cancel, so it's 2 over b in the first term. Nothing can really simplify in the second term here, and then the b's cancel in the last one, so it's just a over 5. For number 3, use the distributive property to simplify the following fractions. As we saw in the example problems, dividing by 4 is the same thing as by multiplying by 1/4. So really, I have 1/4 times 8x plus 12. So if I distribute that, 1/4 times 8x is 2x, and 1/4 times 12 is 3. Here, number 2, we can rewrite this as 1/3 times 9x plus 12. So distributing the 1/3 times 9x is 3x, and 1/3 times 12 is a positive 4. Number 3 can be written as 1/2 times 11x plus 12. 1/2 times 11x is 5.5x, and 1/2 times 12 is 6. 4 can be written as 1/6 times 3y plus 2. Sorry about that. So 1/6 times 3y, so 3 over 6 is 1/2. And 1/6 times 2, so 2 over 6 is 1/3. Notice for number 5, we have this negative sign here. So we're going to make that a negative 1/3 out front that we're actually going to distribute here. So negative 1/3 times 6z is a negative 2z. And negative 1/3 times negative 2 is a positive 2/3. For number 6, we have a 1/3 times 7 minus 6p. So that's 7/3 minus 2p once you distribute. Number 7, I have 1 over 6d times 3d minus 4. And we might have a little bit of work here to do, so 1 over 6d times 3d is 3d over 6d, minus 1 over 6d times 4 is 4 over 6d. So that'll simplify to 1/2 minus 2 over 3d. And the last one, we have 1 over 4gh times 12g plus 8h. So if I were to go ahead and distribute that, I would get 12g over 4gh plus 8h over 4gh. And if I want to go ahead and reduce this further, 12 divided by 4 is 3. Notice those G's cancel. I still have the H in the denominator. 8 divided by 4 is 2. The H is canceled, but I still have the G in the denominator. I'm not so much worried about you being able to simplify this quite yet, but if you can get it written like we did in step 1, that is the most important part. So knowing that you can go ahead and break this up using the distributive property. All right, let's take a look at number 4 here. A bookcase has 5 shelves, and each shelf contains 7 poetry books and 11 novels. How many of each type of book does the bookcase contain? So we can create a distributive property here. So we know that there are 5 shelves, and on one shelf, there are 7 poetry books, so I'm going to let P stand for poetry, and 11 novels, and I'm going to let N stand for novels. So how many of each type? If we can distribute the 5, we know that 7 times 5 is 35, so it would be 35 poetry, and 5 times 11 is 55, so we'll know there will be 55 novels. And the last question we're going to go through, Amar is baking giant holiday cookies for his friends at school. He makes each cookie with 6 ounces of cookie dough and decorates them with macadamia nuts. If Amar has 5 pounds of cookie dough and 6 macadamia nuts, calculate the following. How many full cookies can he make? Well, notice that it's 6 ounces for one cookie. So we're going to have to change our 5 pounds into ounces. So we're going to create a conversion here. So if I have 1 pound is 16 ounces. And I know I have 5 pounds, but how many ounces will that be? We can go ahead and cross multiply. So 1 times x is just x. And 5 times 16 is 80. So we have 80 ounces of cookie dough. Now, how many cookies can he make? Let's take that 80 ounces and divide by 6, because we know each cookie takes 6 ounces. So 80 divided by 6 is 13 1/3. So really, he can only make 13 full cookies because he does have some leftover dough, but he can't make another cookie with that leftover dough. He doesn't have enough. So he's got 13 cookies that he can make. How many macadamia nuts can he put on each cookie? Well, if he has 60 total and he's making 13 cookies, 16 divided by 13 is about 4.61. Well, we can't do 0.61 of a macadamia nut, so we're just going to say that he can put 4 macadamia nuts on each cookie, but he'll have some left over. And then lastly, if 4 cups of flour and 1 cup of sugar went into each pound of cookie dough, how much of each did Amar use to make the 5 pounds of dough? So we can go ahead and use the distributive property again here. So if it's 4 cups of flour and 1 cup of sugar for 1 pound of dough, let's go ahead and multiply that by 5. So distributing, we would get 5 times 4 is 20 cups of flour, and 5 times 1 is 5 cups of sugar. And I'm going to go ahead and sneak my cups into here so that we know the units of measure.